I'm hoping 20 minutes. Yes. When did you send them? Yeah.
It was before this morning they were uploaded. This morning
Good.
the off is broken on data tracker, so we can't upload right now.
Didn't know where to go. Um,
Okay, so we got notes. There's
yeah. All right. Well, so I mean, so we're having a little problem with the data tracker logging in and stuff, but we do have the ability to present things, as you can show. Things I've uploaded, I've got up from the slides. I'm hoping that they will fix it. We'll just keep checking as we go. We have a volunteered note taker, voluntold, as they would say. Thank you very much. um, so let's get to it. Welcome to IETF Dublin. Um, let's see if I can make this work. Blink. So this is the note well. It's the first session of the week. Um, this is a lot of rules and procedures about how we run meetings at the IETF. The big takeaway from this slide really is kind of the IPR rules. If you know something, say something. If I know something and you end up doing a third-party IPR disclosure, uh, you just kind of do it. If you have any questions, definitely ask me or Nick. We can kind of help guide you through that process. But basically, it's pretty clear. If you know something, say something. Um, there's some other things on here about rules and of code of conduct and harassment procedures, but we'll get to those next. This is the kind of highlighting these particular things. Basically, just treat everybody with respect, um, and keep it professional. I guess the other point that they like us to make is that um, if you feel like you've been not treated well in any way, shape, or form, you can tell us. You can tell an AR director. You can tell a buds person. You can speak up for yourself. You can talk to another person in the working group. Do all that. Um, but all right, so there's that. Then we got some meeting tips. Please use the on-site meeting tool. Scan the QR code, which was up. I don't know where it went. But that helps make sure that we get an appropriate size room. It's also how we end up doing queue management. I guess, Richard, the QR code's on the thing, right? Or it's in multiple places. Cool. So yeah, please make sure to scan that so that we know what's going on and how big the room is. All right, and then the next thing, this is our long list of drafts. I want to thank the group of people that pulled together our agenda, where we're basically going to do this administrative stuff. We're going to do a dance because we all got rechartered. So there we go. That's our 5-second dance. And then we're going to talk about the multitude of extensions we have. We have one document that is specifically called MLS extensions, and then we just have a lot more. And so we kind of wrote down all these. I know that Joelle is going to be presenting remotely. It should work hopefully. And then we have two other drafts here, or three other drafts technically, I guess, that we're probably not going to have slides, but there are out there for decisions. So for us, really, since we're rechartered specifically due to extensions, my thinking really is with Nick is that we have to figure out how to triage these. Because with this long list of extensions, what goes in the extensions documents, when we want to do it, how do we prioritize them? Because I think if we did all of these at once, we'll do nothing. We'll just spin our wheels. So basically, that's what I'm hoping you're going to be. I was going to be able to keep in mind for today. Do you need to add anything, Nick? All right, cool. I'm going to stop sharing these. I'm going to hope that I got combiners, I got MLS topics. I do not have Raphael's slides. So is there, no, so the problem is I got them, but I can't share them.
yeah, they're not on the data tracker.
They're not on the data tracker. So
Is there an HDMI cable? Yeah.
mm, I don't know what that is. Oh, over there.
Does the Meet Echo
Yeah,
tool work?
it does.
Can you request sharing slides?
Yes. So I think if you log in and you do share slot or share screen, then I think you can. Yeah. So yeah, it should. Is it just going to work? Yeah, that's what I was looking for. So I think if you retry it, I'll hit the button. I saw it go by. Oh, hold on. Okay, and why can't I hit like yes? Okay. All right, I see an agenda. The data tracker is coming to life. All right, let me get here. Sorry, folks. That's that. It's funny because like the only thing I see is an X, which would mean I'm saying no to it, right? Okay, hold on. 1 second. Ooh. You got it to work?
Yeah, so it's doing, there's a few slides apparently.
Oh, all right. Yeah.
Yeah, can you request again? Because I think, hold on 1 second. It gave me 2 options.
I'm only seeing one on the phone.
And there's grant preloaded slides and refuse slots request for 0 options.
All right. Yeah, that's all right. Cool.
Do you have the email to output?
I do, I think. Let me try to get link materials, upload new slides, browse, extensions, link. Sorry about this, guys. Upload. All right, now they are there. So now it's going to take a second. There we go. I have it. We have the technology. All right, there we go. Just let me know when. I think you have to get closer. Yeah. So let's. That one got a button on it. Did you got to press? It's on now. All right. Well, you know what? You're gonna get to be a rock star. Sounds like it is.
All right. Ooh, wow. That one works. All right. Then we can finally start. So try to put some names on here. I hope that's all the author names from all the extensions we're going to discuss today. Hope I didn't forget anyone. Next slide, please. So yeah, that's the quick agenda. Obviously, we didn't really coordinate between the chairs and I regarding the list of extensions. So you're going to see that again. Next slide, please. So yeah, you already saw that. Next slide, please. So yeah, there are 2 other drafts I wanted to mention quickly. The paired MLS, so that's currently on hold because of the virtual clients draft. Depending on how that turns out, paired MLS is going to be picked up again or dropped. And the other one was the membership proof extension from Rowan that got retracted completely. Next slide. So yeah, there hasn't been a lot of work on the MLS extensions document. Published a draft not long ago. So this is a list of what changed. It's really short. There's a new extension state, which is there to coordinate the state of extensions and how it can be shared between extensions. There's a very useful safe AAD extension that is part of the safe extension framework that allows to essentially structure the bytes that go into the AAD, so that different safe extensions don't collide when they want to write stuff into the AAD. And then there's some early clarification on how capabilities can be negotiated in the context of the safe extensions framework, but I think we're going to get back to that in a bit. Next slide. There's also some work in progress. There are two PRs currently. One is about additional credentials. That is not finished. The other one is about group context extension encryption. That's also, I think, in the very early stage. There are a few issues, but none of them are actually major. It's just editorial stuff or some mechanical changes we need to do. There was also some early feedback from IANA that is now addressed. Next slide, please. So yeah, this is something Ron is gonna get to in a minute. So just a little intro. We've had some discussion about what an extension actually is, how that works. We discovered the word extension is quite overloaded, because on one hand, it's something that goes into the ANA registries. On the other hand, any draft that is not the main spec is an extension. So it's not quite clear what we mean with that. So we need some discussion around that. We already have the safe extension framework. And we also have some ways how you can extend MLS. Some predefined ways, because we have the IANA registries in a number of places, but not in all of them. One of the things we noticed is that we don't have a registry. So we don't have a capability to negotiate different wire formats. So that is something we omitted. So yeah, I think Ron is going to present an idea of how we can get out of that. We don't have complete consensus on the details yet. It's probably something we're going to discuss at an interim, if nothing else. And I think that was the last slide before the extension I'm going to present at the end. Yeah, Ron, you're up next.
Negotiation slides, is that what we're talking about?
Yeah.
Seems like it's flash out.
Yeah, I think the battery is what I did.
Yeah, I
Turn it on and off.
Yeah, oh, here we go. Say the rest. Hello.
Hi.
No, don't.
This is the one that works. Just the one over there that doesn't work.
That's the one that's not working.
Correct.
Yeah.
Something as simple as 2 AA batteries.
It seems very likely, in fact.
Are you happy to use that for the moment?
Yes, thank you very much.
All right, as you were.
All right. So I will just start by saying that in addition to the 2 different meanings of extension that Raphael mentioned, there's a third meaning that we also use, which is that the individual component that is being extended. So a specific proposal or a specific proposal type or a specific group context extension or so on and so forth. Next slide, please. Okay, so these are the places where we currently have MLS extensions that are allowed in some way, shape, or form. Cipher suites, wire formats. I'm going to skip over this third one and come back to it in a second. Proposal types, credential types, signature labels, public key encryption labels, exporter labels, pre-shared keys, and additional authenticated data. The last 2 are added in the safe extensions framework, which is described in section 2 of the MLS extensions draft. The third place is on this list is called extension types, confusingly, in the IANA registry and in RFC 9420. In the extensions draft, I call them core struct extensions because they affect 4 core structs: the group context, group info, key package, and leaf node. So those places have an extension point that's called extension type or extension. Next slide, please. So the negotiation mechanism in MLS is that we have this capability struct that goes in a leaf node and a required capability struct that goes in a group context. Unfortunately, these only have, so like for example, in required capabilities, since a group only has a single protocol version and a single cipher suite, you can't say that you require some different protocol version or some different cipher suite than the one that you're using in the group. So that's totally okay. But you can say these are the core struct extensions that you require. These are the proposal types that you require, and these are the credential type you require. You can't say anything about wire formats, for example, there. But most importantly, for any of these other sort of obscure things like labels or AAD or PSKs, you don't have a way to signal that you support or require those things. Next slide, please. So I made the observation on the list that sometimes what we mean is that we want to talk about a feature. So if we take, for example, the associated parties draft, it is a set of functionality that you want to be able to implement or not implement altogether. And so, for example, this has one group context extension, one group info extension, 3 proposal types, and I don't know, I think it at least has one exporter label. It may have 2 exporter labels. I wasn't super clear on that when I was writing these slides at 6 o'clock this morning. But so what we want in terms of the capabilities and required capabilities, I believe, is to be able to say, I support this feature. When we send a message inside of MLS that uses one of these, we need to signal a single, we need to be able to differentiate a single proposal or a single, the semantics of a single proposal or the semantics of a single group context extension. So that's where these things are a little bit different. The difference between a single extension and a feature, which could be a single extension or a bundle of extensions. This interacts as well with the safe extensions framework, because the safe extensions framework has a concept of domain separation. And here we want to be able to say, all right, I have a group context extension that's used for associated parties, and that can be modified by other parts of the associated parties feature, but not by other features. So we have these questions. How does the MLS stack know which extensions belong to a specific feature so that it knows which of them can share a domain? How does the MLS stack distinguish, for example, 2 proposals belonging to the same safe feature? As in the case of, we have the associated party draft has 3 proposal types. And how does the MLS stack know if, for proposals, if an update path is required or if external proposals are allowed for a specific safe proposal?
Rowan, could you elaborate a little bit why you think the MLS stack needs to know these things?
So if there's
sorry, to be clear, needs to know them in some sort of generic sense, as opposed to that being the way that a specific feature is implemented.
Okay, yeah. So what I was going to say next is that it needs to, the stack needs to know this. It could be that it determines this by looking at the extensions, or it could be configured to do that. But if it has to be configured to do that, that's potentially a very error-prone mechanism. And so you could configure the stack to do, domain separation in such a way that a feature doesn't work because one of the extensions that belongs to that feature is not allowed to access that data. Or you could do something that allows an attacker to access data that's in a totally different domain. Is that good enough? Okay. All right. So I noticed this when I was trying to turn several extensions that I wrote into safe extensions, and then fortunately Conrad wrote a very useful draft called Associated Parties, which is a safe extension and has the problem of having multiple proposal types. So um, together I was able to come up with examples of basically all of the problems that I was worried about. Um, so according to the safe extensions framework, um, in order to access the associated parties group context data, um, all of the uh, everything that accesses that um, needs to be using the same extension number or extension type, even though it has 3 different proposals. So those 3 proposals, they all modify the data that's in the single group context extension. As well, the 3 proposal types need to be distinguishable on the wire from each other. So, someone who receives an associated parties add needs to be able to distinguish that from an associated parties remove or an associated parties update. Next slide, please. Okay. And just as a reminder, safe extensions for proposals is a little bit unusual in that it registers 3 generic proposal types in the IANA proposal types registry. One called extension proposal, one called extension path proposal, one called extension external proposal. So these are respectively a regular proposal that can't be used, that has to be used by a member, that doesn't require an update path. The second one is one used by a regular member that does require an update path. And the third one is an extension that can be used by either a member or an external proposer. And in that case, also update path is not required. But if one safe feature has multiple proposals, there's no way to distinguish them. So if I, inside of any safe extension, like a safe proposal, there is the extension type, which really is sort of like the feature type. And if you have 2 proposals that arrive on the wire and both of them have the same number, you can't really tell one is a remove and the other is an update. So if we decided we wanted to register safe proposals individually, then the stack would need to be separately configured to know that an update path was required or not required, and that would be another piece of configuration information, which would be very difficult to get correct. It would have security implications. Next slide, please. Okay. Go ahead, Conrad.
Sorry, just one note. And at least in my mind, the way that we intended it to work when writing the safe extension stuff, and I admit I didn't do that in the the associated parties draft, is that you have an internal discriminator, as we talked before. So you can distinguish them. You just have to do the distinguishing kind of as the writer of the proposal. You have to build that in yourself. It's not provided by some framework.
Right. Okay. So I have a concrete proposal, and I understand that it's unlikely we're going to come to consensus here, but I wanted to get people to get eyeballs on this. So the first idea is that we've got features, and the safe extensions framework basically says go register them in the extension types registry, which currently doesn't allow that, but we can modify that to allow that. So it currently only allows these core structs, but we could reserve a range, a part of that registry for these features, and each feature being a cluster of related extensions. And this could be for either safe or non-safe features. And these things would appear in the capabilities dot extensions struct in that vector, and in the required capabilities dot extension types vector. So you would be able to negotiate those. So if I had, for example, the self-remove proposal type, I would advertise support for that in the capabilities dot extensions and required capabilities dot extension types if my group wanted to require self-remove. All right. The next part is that we would clarify that new safe proposal types and new and credential types do not appear individually in the proposals and credentials sections of capabilities and required capabilities, because we already have in the case of proposals, we have these 3 different types reserved in the proposal types registry, and we have one for the credential types registry. Non-safe ones would still appear individually in those registries. And we would put the generic types for whatever generic types were supported. In the case of proposals, there are 3 of those types. So whichever of those 3 types were supported, we would stick those in capabilities and required capabilities. So this actually, in the draft right now, it says this already here. It doesn't say the first one, but it does say the second one. All right, moving on. So for safe proposal types and safe wire formats, on the wire, when you send the proposal or send the new wire format, you would use the generic safe extension proposal type or wire format type. Inside of that, there is an extension content, which then references the feature identifier. And then if you have multiple items of the same type in a single feature, then you would put a discriminator as the beginning thing in your structs when you define a new feature that has those multiple items. So I think this all works. Oh, and lastly, we would add a new supported wire formats leaf node extension and a new required wire formats group context extension, so that we could tell whether you supported different wire formats and whether a group requires additional wire formats. Richard.
I hate all of this. I mean, the bottom bullet, yes, absolutely, we should do that. Easy, quick fix, bug fix, clear omission. The rest of it, I feel like we worked ourselves into a well of complexity with a bunch of extra assumptions we've made in safe extension, the way safe extensions is structured right now, which attempts to bolt a bunch of extra structure onto MLS, which I think is non-critical for the core protocol. So I'll take an action here to file an issue and elaborate exactly what I think is overdone in safe extensions, because I think all of this is downstream of the safe extensions.
I don't think that's sufficient.
Oh, okay.
I think you would have to write an alternate proposal for how we do negotiation.
Well, I question if we don't have this, so all of what you've been talking about here basically treats, well, to first order, this all treats, it flows from the fact that you're viewing an MLS stack as holding a bunch of data and policing security boundaries among that data. None of which is necessarily true. Like, that's all extra assumptions that were added and some other stuff. So to the degree where that as a driving case, I think we should fix that and get rid of that as remove that assumption from our starting point. So that's the issue I promised to file, is to clarify that and get that discussion started. There may still be some multi extension level negotiation that we still need after we strip all that, but I think it's a much smaller problem. Probably deserves. I think we're going to use the phrase, we should have some virtual interims on this for the chairs. I think this is probably one where that would be useful.
That's 2 weeks from Wednesday. Yeah. Okay, any other questions or comments about this? Okay. So, I mean, I think the good news is that we have we have implementers from at least 4 of the MLS stacks here in the room. So, and hopefully one more online. So, thank you.
Who's next? I'm only going here because I'm trying to figure out selections. So we have those. Were they? You're up next.
Richard's in the queue.
You can take me out.
Okay.
Objecting already. Okay, so this one is about MLS combiners, particularly for post-quantum, and how we can do hybridization. This has already been briefed. We have, in the last several IETFs, we kind of survey the room of different priority areas, and we narrowed it down again, and so this is where we've gone to today. Next slide, please. So this particular hybrid version is actually focused on flexibility. That's the whole motivation for this version, is flexibility. If you look at how hybridization works today across different messengers, there's usually kind of 2 extremes. Either you do a post-quantum traditional instantiation of your conversation, and from then on it's traditional only. So you say, I've got post-quantum security, but I'm only inheriting it from the first epoch. Or you do a hybrid at every single ratchet. And of course, it's going to cost you because of all the overhead associated with that. So the question is, can we get a middle ground? Can we actually have it flexible based on a particular implementation of how often you want to do your post-quantum ratchet and have that built in as the natural basis? Flexibility also goes a little bit further here. The whole point of doing this as a hybrid isn't strictly about combining the post-quantum and traditional guarantees. It's saying, I want a post-quantum session that is ratcheted. However, for whatever reason, I may not be able to afford the cost of doing that all the time. So in this case, we're actually leveraging a hybrid as a way of lightening or amortizing the cost of doing post-quantum updates. And that's the whole point of doing the hybrid, is actually doing a post-quantum session, but amortizing the cost of that. So that's the motivation. Next slide, please. Here's the basic combiner principle that we have narrowed down to. It is very simple. At the outset, you have a post-quantum group, you have a traditional group. These are actually considered to instantiate entirely separately. It will have all the same membership, so that's keeps things nice and simple. And we have a sequence of either partial commits or full commits. So a partial commit is your traditional commit, and you're going to ratchet that as often as you'd like. A full commit, how that works, is you are going to ratchet your post-quantum session. You then generate out a exporter key from that using MLS's already existing exporter key function, and then use it as a PSK for an inject into the standard group. So in other words, you're running 2 parallel groups, and you're taking the post-quantum group to inject into the standard group. And for this, you're then ending up with a hybrid security for confidentiality in the standard group, and all your messages are sent under the standard group. So the post-quantum group is only there for ratcheting when and however often you want to ratchet that. Next slide, please. So we have, since the last IETF, we actually have produced 2 modes, options out of this. There's a confidentiality only mode, as I mentioned before. All your messages are sent in the standard group. You've already injected your post-quantum into that, so you're getting your confidentiality out of that. We also have an authenticity, a confidentiality plus authenticity mode. This is where it gets a bit more fun. We can actually get post-quantum authenticity. Not post-quantum non-repudiation, but we do get post-quantum authenticity if we are signing our updates in the post-quantum group with a post-quantum signature. But again, we're amortizing the cost of that and doing it as often or less often as you'd like for a given implementation, so you can adjust accordingly. Next slide, please. So here's just a few examples of how this can work and why it's so tunable per implementation. Your first one here is your basic one that says, I can do a single full commit at the start of this session. So when I instantiate the group, I do my post-quantum inject, and I only do that once, and I leave the post-quantum group from then on and pretty much forget about it or delete it. I don't do anything else with that group. And once it's injected, I do all my ratchets in the standard group. So a very simple case. And you get you get your post-quantum traditional confidentiality, but not too much on the authenticity side for anything else. And then you can do, I'll say, semi-frequent full commits in a confidentiality only mode. And this increases your essentially your post-quantum ratchet. But again, you haven't introduced anything for data authenticity. You could also use the confidentiality and authenticity mode and then do, say, frequent full commits. You can also do this in the one-time full commit if you'd like. And you get data authenticity out of that one, but again, not non-repudiation. The reason why is that it's going into the AAD, so that's where your authenticity is coming from in a symmetric case, but you're not using post-quantum signatures in your standard group, so you're not getting non-repudiation. So this is sort of I'll say trade-off benefits of whether you really need post-quantum non-repudiation. It's up to you. We can go there, but we haven't done so in this draft because that does cost you. So that's the high-level view of this particular draft. And any questions? I shaved off time.
All right, so now we'll do some chair things. Who's read the draft? All right, I mean, that's a pretty good number actually, because what we're trying to figure out is now we have all these extensions, they're individual drafts, or we're going to adopt them as a working group item. So I guess if people have reviewed this and I don't see people lining up to the microphone to say that like, I hate this idea, we're in the process of trying to figure out whether we're gonna start said working group last call. So okay, I see people reaching for their phone, so feel free to jump in.
Yeah, so what I find really interesting is the difference between authenticity and non-repudiation here. And I really need to wrap my head around that. And maybe I'm not the only one. Because, yeah, it seems really subtle. I think it would be good to better understand what that gives us to use post-quantum secure signatures in the PQ group, but then not in general.
Yeah, so good question. And we expanded on this in the newest security section on the draft. What's happening is you're doing your updates with the post-quantum signatures in the post-quantum group only. And we went through all the options of doing hybrid signatures or post-quantum only signatures or post-quantum in each group and all that stuff. It actually came down that there weren't a whole lot of trade-offs or benefits from doing all those other combinations. And so actually keeping it simple got us pretty much the best of all worlds. And so what we do is the post-quantum signatures on the updates. So now you know where those have come from in post-quantum view. Those have then been injected, of course, into this key schedule, so you're coming out in your AAD. The only thing that you're not getting is anything that you sign, because when it comes down to actually sending messages, now you've done an AAD over them in the standard group that has gotten your keys through this whole key infrastructure that involves post-quantum. Those now have authenticity on them under the AAD. Anything not under the AAD isn't getting post-quantum authenticity. So that includes if you do a standard signature in the standard group. So you get there's a little bit here of far nuances what you can get in terms of trade-off of if you're an insider or an outsider threat. Because if you're an insider threat, of course, if you say someone in my group, if I'm in a company and someone in my group has a quantum computer is going to attack the group,
Yeah,
then okay,
that's what it means,
you could argue that you got some problems. But if you say no, I'm just going to have an insider threat that's standardish, and my quantum attacker external, then you've got plenty here.
Yeah. Okay. Yeah. No, that's very helpful. So that means, just let me rephrase it to make sure I understood it. It means that in theory, you still have a problem if an insider has a post-quantum computer, quantum computer. Sorry.
Yes, yeah,
but since that's a very unlikely scenario, you know, for logical reasons, we decide to, well, not take that into account in reality.
Yeah.
Correct. Okay. Yeah. Well, that's very meaningful. Thank you. And yeah, just for the record, I think initially you also looked at another way of doing it by combining it directly at the HPKE level, and that's not what we ended up doing, obviously. And I think it's a good thing. This is the right way to go, and we should implement this.
Okay, I'm going to say the opposite. I think that it should be done on the HPKE level. At least the combination of the schemes, like the way that you combine like X25519 and MLKM and so on, should be on the HPKE level. I do think that you can do this anyway, though. You just say you have two different HPKE public keys, one that happens to only be classic and X25519 and very small, and create a very small ciphertext, and one that just happens to be X-Ring. So I think that way you get sort of the best of both proposals of like having a nice, well-defined combiner on the HPKE level that like does the combination, and getting the performance improvements that you get from maybe not having every commit be full post-quantum, because like you have the symmetric ratchet there that protects you anyway. I think that might be like, that would be my favorite outcome of these like back-to-back kind of contradicting proposals that we have scheduled.
Great. Thanks for the input.
Yeah.
So that was actually one of the proposals discussed at IETF 119, because we had these different options, and we're still open to doing that if there's demand. At that point, we put it to the working group and said, which direction you guys want to take? And most went in this direction. But if there's demand for that, absolutely, we're definitely open to going that direction. We sketched out how that draft would look. It is more invasive to the protocol because the protocol itself only allows like one key there as far as one signature and all that stuff. So we're actually starting to get into changing some of the protocol infrastructure, whereas this is modular outside the core protocol. It's an option, but that's the trade-off point.
Yeah, what I got to say is basically that, like, there are these two options if you want this sort of independent timelines property. You can do it internally, like you said, or you can do it around the side. I like this approach a lot better because it doesn't perturb a lot of the protocol internals, and require new protocol messages and things like that. I mean, yeah. Let me just, I'll rephrase that because Sophie didn't come. Like, it gives you kind of a meta protocol that you need to consider in the overall envelope. I agree. It just seems a little easier to think about, but there's absolutely a design space that the working group could decide on here. I'm okay with this approach. I don't think it's contradictory with the hybrid, just have an X-Wing cipher suite approach that I think Rowan's about to talk about. I'm reminded of the days of secure HTTP where there was SHTTP and HTTPS, and one of those won and the other didn't, and we just carried on.
Hi, Rowan May. So I was going to say, we also have proposal to do both pure MLChem cipher suites and hybrid MLChem cipher suites, and that we didn't, like most of the the authors of those drafts did not feel that this was contradictory or like in any way detracted one from the other. So I support adopting this, and I also support doing some cipher suites. Thanks.
Sounds good. Looks like the end of the line. So right on time.
Yeah, so I think what we're going to do is we are going to try to run a working group last call to figure out if we can get everything documented out. And if it ends up getting stuck, then we're going to have another interim on this. I mean, I feel like we're going to make judicious use of the virtual interims to try to get through this, because we've been talking about this draft for like a year and a half. So it's time to get on with it.
Part of that was the recharter, but
yeah, fair enough.
But I will just advocate that Sophie or folks that have have opinions on this design question, like this adoption call, would be a good time to opine on that on the list.
Yes. Excellent. Okay, we are now actually going to go back to the regularly scheduled program. I even have the agenda up here, so I know who's supposed to speak next. And I believe, yeah, X-Wing. All right, cool. And that is in no slides. All right, cool. That makes it easy.
Hi. So for the cipher suites, we are waiting for drafts that register HPKE chems to be slightly more mature. They were nearly there, but not quite. So I'm going to update a draft so that we have cipher suites for plain MLChem chems of the three, or at least, yeah, of the three key lengths, and 3 particular combinations. So MLChem 768 plus X25519, MLChem 768 plus P256, and MLChem 1024 plus P384. Thank you.
Absent, Richard.
So I'm going to talk about some bad assumptions that we made in RFC 9420, or some assumptions we made at the time, which might be worth revisiting now in the light of deployed reality. So this is a combined discussion between 2 things. We talked about AppSync last time, or the last couple of times, because that's a requirement coming out of MIMI. But if you squint your eyes right, this actually turns into a much more generic problem with how we manage extensions, and extensions in the concrete sense of what you have on your group context, not the like very broad abstract form that Rowan was talking, not features, clearly. Next slide. So we made 2 simplifying assumptions when we were figuring out the extensibility story in base MLS. So one, we assumed that, so you have a group context in MLS, it's got a bunch of extensions hung off of it. And we assumed that you could update them just by sending a whole, here's all the new group context extensions. There's no diff algorithm. I just give you the new thing. So that's very simple. We went with that for the initial one under the theory that we have these extensions and we could extend the protocol in the future to do fancier stuff. We may be doing that now. Second simplifying assumption we made was that you can decide whether a commit needs an update path, whether you need to send new entropy to the group, just based on which proposals are being implemented, just on the proposal type, without looking at the content of the proposals, just looking at their types. So these are the 2 assumptions that I think we might need to revisit. Next slide, please. So this first one starts to be a problem if your application is storing stuff in these MLS extensions, and like maybe storing a lot of stuff. Like maybe you store a list of participants in a messaging room in an extension, and there's like 1,000 participants in there, or maybe there's certificates for those participants there. So I don't know, a lot of data. So if you're just resending all of that whenever anything changes, if Imad joins the room, I've got to send everyone's name out to everyone else. That gets expensive. The second thing is that this group context extensions proposal, because it can change anything, can change any extension, which has any semantics we want, arbitrarily change the protocol this way. We have to assume for safety that that could do something where we need to send new entropy to the group. And so if you send this group context extensions proposal, you always have to send an update path just to make sure we're safe. Even if you're only changing like totally innocuous stuff, you're just changing the room title or something, like doesn't matter. You still have to chem new entropy. So that gets real expensive again, because these update paths can be linear size. So next slide, please. Yeah, so the question is, should we revisit these assumptions? So doing diffs, Rowan put together a doc on GCE diff. So this, the proposal here is to like have, instead of group context extensions, a group context extension diff proposal, where you provide a diff on each proposal type. You label things by proposal type. There's an assumption here that you only have one of each type. I think we can go with that. But anyway, you can add, remove, diff. I think we can probably roll replace into diff, by the way, but whatever. Add, remove, diff, and have basically diffs on extensions, so that we don't have to send the whole thing. Pretty simple, pretty modular. Now the one little nit here is that right now this GCE proposal can just be applied entirely internal to MLS because there's no validation rules. You just replace the data. Here, as we're doing diffs, a diff might not apply to the current state of an extension. So there, maybe we need to import a lot more state into the MLS stack in order to be able to track these diffs and whether they apply and validate that they're correct. Or we might need to have some, interface between the MLS stack and the application to validate these proposals before they get applied. So there's potentially a little bit more complexity here if we add this additional functionality. Next slide. Yeah, this one is a little more subtle, because there's this question of how we determine, because so the proposal here would be like, say, right now we have this path thing based on the proposal type that, so because you always apply it or do or don't require an update path based on the type of the proposal. So if we were going to define this, GCE-def and loosen this pure proposal type requirement, you would basically, you might register it with path equals no, and then have some spec text that says, if you do some sufficiently dangerous thing or you don't do only safe things, then even though you wouldn't otherwise be required to, then you really have to uh, have the update path. So like the logic for deciding whether you need an update path now gets a little more complicated, or potentially a lot more complicated. We have to decide like what that path required boundary is.
In other words, we would add an IN, a registered maybe to this table.
Yeah, or conditional or something like that. Oh, one thought that occurred to me just as I was writing this was like, maybe you could do this by pushing that path required thing down to the extension level. So like if you can modify this extension freely, my room title extension, like you can change that. You never need an update path. Like don't worry about that one. But the associated parties extension that decides what keys get um, you know get extra information about this group. Like maybe we always want to have entropy when we send that. So you could do this at the extension level. That's still a little coarse grained if you really want to be precise about it, but it would be potentially an easy way to think. So I think that's the big to do. The big risk here is that we'd have to decide what that boundary is when we want to require update paths. The alternative, which Rowan proposed to me, was that we could just make a pure application data one. So like basically take this idea of applications that are safe without an update path, that are pure application data that MLS doesn't really care about except confirming agreement, and put that in a, basically do the same diff stuff, same mechanics as the group context diff, but declare that this extension itself is just application data. And so you never need to worry about sending an update path along with it. So we could kind of split at the proposal level, or we could try and distinguish within a proposal type. So those are it's kind of the design space. I think that may be my last slide. Yeah, that was the last slide on that topic. So I think we've got two drafts right now, one for GCE-def, one for AppSync. Depending on how folks feel about these two questions, like we could merge those, we could do nothing. But I think just to put a concrete proposal on the table, I would probably propose we do GCE-def and take a stab at doing AppSync, making this distinction about whether we require a path or not, or doing AppSync as kind of a subset, a single paragraph at the end of GCE-def, which says, here's an instance of it that you never need a path for. So yeah, the proposal would be to kind of adopt the GCE-def draft and kind of go from there. But happy if folks have other thoughts. That's all the content I've got.
Yeah, just a quick question about the group context extension. Is there any overlap with encrypted group context extensions?
I
That
haven't
Rowan was
looked at that,
proposing.
so I don't know.
Okay,
Probably.
so that is only an early stage PR on the extensions document, but it would be interesting to see what the common ground is and not develop that completely separately from each other.
Yep, sure.
But yeah, I'm not holding any stakes in any of that.
Yeah, I don't know. I'd expect that an encrypted group context blob would just be, if it was application data that was encrypted, then you could wholesale replace it with an AppSync or a GC diff, and that would be just fine, and that wouldn't be a problem. If there's, if we go down that path and realize that, oh, that doesn't work, then then maybe we need to do something else. But I think that this would work fine with that for what I've done, the research I've done on it so far.
You could do encrypted diffs. fully
Not-
homomorphic diffs.
Not so sure about that. Yeah, Conrad Kohlbrock. I just wanted to say that, I mean, this is one option, but I don't think this should be required for extensions to use, right? Extensions can still define their own proposals that have a potentially very smart way of modifying the state. And then, you know, and this path required stuff is one of the things we try to solve with these different extension proposals. And then you could, you know, pick the proposal type you want. Thus, you know, communicate the semantics of the whether you require a path or not. But this is fine to have. It makes it easier for extension authors for sure. Cool.
Other thoughts? Anyone in the queue? All right. Thank you.
So just to be clear, you want us to do an adoption call on this, or?
Rowan, maybe you and I should do another rev on GCEDIF just to kind of clean it up and prepare for adoption. But yeah, I think this is pretty well ready. It's pretty simple.
Associated parties.
Not absent, associated parties. Okay, so associated parties, something that came out of the need of other extensions to have secret key material that all group members know, but also that they share with another party that's not a group member. And specifically, in Mimi, this popped up for Rohan's extension for the semi-private messages and the franking extension. Next slide, please. So essentially, just for a bit of detail, if you have a federated infrastructure and messages passed not just through one entity or one server, but through multiple, and you have only one server that you actually want to see the message, semi-private messages is a way of doing that. And for that, you need to share some key material with that server that you want to have be able to inspect the messages. And there might be other features where you want to share key material between not just in the group, but also with another party. And this is just a generic way of doing that. Next slide, please. Yeah, so the general overview is that whoever wants to be in a position to share key material with a group, publish like a thing like that's very much like a key package in general MLS parlance. And I mean, this whole extension is essentially just what we already have in MLS with the external senders mechanism, where external parties can send proposals to an MLS group as a public message. And this just beefs it up a little bit to make the association a bit closer to the group. And so similar to the external parties, there's a group context extension that lists the associated parties so that everyone agrees on who that is. Then group members can manage this list through proposals. And in each epoch, there is a secret exported from the MLS key schedule that's then sent to each of the parties. And each of the parties have a key schedule associated with them that's kind of tracking in parallel with the MLS key schedule. And also then in addition to feeding randomness from the MLS key schedule to the associated parties key schedule, the associated parties can themselves contribute randomness to their respective key schedule. Next slide, please. So yeah, the rough life cycle again is that these associated parties publish associated party entry structs. Essentially, again, they're similar to leaf nodes. They have a credential in them. They have a signature public key and an HPKE key. And there's now the potential to have, to have them also have capabilities and have extensions that work for these associated parties. And we have a whole, complex thing if we wanted to, if there's need for that. But for now, this is really simple. I see Richard doesn't like it right off the bat. Yeah, and then you have this list of associated parties, as I said, in the group context. And then that's managed via these add, update, remove, similar to how MLS group members are actually managed. Next slide, please. And then this is roughly how the two key schedules interact. You have the MLS key schedule on the left side. There we export something that then this AP commit secret gets camped to the respective associated parties. And then we have the second, for each associated party, you have a second key schedule that can take from the right side an AP proposal secret that would be coming from the associated party itself, feed into the key schedule, and then from that you get an epoch secret from which you can export secrets that you can then use for semi-private messages or franking or what have you. And then from there you have the AP init secret, which is then used to initiate the next epoch. So it's essentially a mini clone of the MLS key schedule itself. Next slide, please. And then finally, we have to solve the problem of onboarding new group members. And again, that's solved in a very similar way to how we do it for the MLS key schedule. The welcome needs to contain the key material that new members need to actually also take part in the associated party key schedules. And if you have an external joiner, just like in the MLS key schedule, the external joiner essentially cuts the key schedule of all associated parties and sets the new init secret and chem that to the rest of the group, just like the init secret for the MLS key schedule. There's a draft. Rowan has already sent me a lot of feedback, which is great. I'd be grateful to have more feedback, especially if you want to have this be more complex with capabilities and extensions. I'm doubtful, but if there's need for that, we could do it. And otherwise, yeah, that's it from the associated parties stuff. Any questions?
I can't find the media echo thing, so I'm Richard Barnes. Yeah, this is elaborate. So yeah, your point about it kind of being a mini MLS key schedule, I think, is quite salient, especially because we've added add, remove, and update proposals. At this point, I kind of wonder if there's a transform like what Brita did, where you want a you're importing entropy from one group to another group. In that case, I wonder if this case, what you're really after here, if you really want all of this key schedule stuff, is you just have another group, which is the external parties, and you also encrypt to that group, or something like that. I admit that, like, when I came to this problem, as it came out of Mimi, I was thinking this would just be simple. You'd have like a list of chem keys, and when you do a thing, you chem, you encrypt, when you encrypt a message or something, you also chem to those keys, and there's no fancy management. It's just a list of keys in an extension. You have one proposal that replaces the list of keys, and it's fairly simple. So I'm wondering, like, one, what is all this extra complexity buying you? And two, like, if we're going to undertake that complexity, maybe we should just reuse MLS.
Good points. So I think if you look a bit more closely, it's not that much extra complexity. So for this whole kind of key schedule, like publishing key material stuff, that's just, the key material has to come from somewhere. And so we can either just leave that up in the open and say, there is a list, people can, but then that list has to be modified. How do we modify it? We can use proposals. What else would you do? You could have a group context extension, I guess, or we could use this management stuff. That will work. I'd be happy to use that. And the key schedule is really just writing a relatively cheap way of getting, chaining the randomness so that you get slightly nicer forward secrecy and post-compromise guarantees. We could remove the ability for associated parties to contribute randomness. Like, if no one really needs that, I'd be happy to remove it. And then there's not that much complexity left. I thought about using an MLS group for that, but then you have the MLS group that only has the associated parties with it, but then all the parties know the secrets. Like, you can't have different secrets for different associated parties. And also the clients really don't have any that are in the regular MLS group, don't really have any insight into that other group. They don't really. So either it's a super group that contains both the clients and the associated parties, but then that's a lot of extra stuff to manage. But otherwise, the clients are all external senders to the associated parties group. So I'm wondering if that's not more complexity or rather than less. But I'm happy to, spin that a bit more. Yeah, Ron.
Yeah. So I was gonna mention that the way the associated parties draft is written, it may have been a little bit unclear. Like, it's pretty subtle. It's just mentioned in like two sentences, but for each associated party, there's a separate key schedule. So, like, you wouldn't have like a group with all of the associated parties. You'd have one group per associated party. So now in this case, associated party, maybe what you mean by an associated party is like a high availability cluster, but not like my moderation service and my hub, and this other thing that needs access to keying material, but I'd have like one associated party's key schedule for the hub and one for the moderation thing and one for something else. So while I'm going to say in general, I don't actually care what we end up working with, um, as long as we have a solution to get keying material to the, specifically to the hub for Mimi. Um, I I will say that it was refreshingly easy to reason about the security properties when using the key schedule with associated parties. Like it was just like, oh yeah, I understand what the security of this is going to be. Um, so that's my only, and it's been pretty rare in this group that I've like encountered a new extension and been like, oh yeah, I know exactly what the security is like, and I'm not a crypto person. So thanks.
Yeah, just really quickly, in response to what Richard said, I want to respond with what Richard usually says. That is, keep it simple. And because I think the idea to put all the associated parties in a group introduces a lot of complexity, because it gives them the ability, of course, to also confidentially exchange information, which was not a requirement at all so far. But it also means they need to synchronize and whatnot. They need their own DS, etc. Maybe there's an idea in there to generally think about how two distinct groups can, exchange information in general, and then that could be applied later. But for now, for the sake of making progress, I really think we should keep it simple, and what Ron just said illustrates that pretty well.
I mean, don't get me wrong. I looked at this list of associated parties and I thought, isn't there a way to distribute the key material more efficiently? Couldn't I make this a tree? And then I went down the rabbit hole and came back up and, just forgot everything. So yeah, Britta.
Britta Hale. I'll echo what Rowan said, that I really like the security clear implications of this. So, I mean, we can discuss implementation trade-offs and whatnot of other groups, but I think this is very nice in its simplicity.
So since the chairs keep asking us about this adoption question, what I'm wondering is whether we feel like we've got enough. I feel like there's fair agreement on the problem. This is a problem we should solve. I wonder if we're kind of consolidated enough on approach at this point to be ready to adopt a document. I'm kind of feeling like no, but obviously I have some strong feelings in different directions here.
No, I mean, I'm not in a rush. We can take our time to work this out and do the rest in an interim at some point if we feel more confident as a group. Yeah. Yeah, Deirdre.
Deirdre Connolly. I helped read this and made the key derivation and domain separation a little explicit. I like it. I do not think it's very complex. And what Rowan said of like, it's very clear and obvious the security properties of doing it this way. It might need a little bit more eyes before adoption call, but I support adoption.
Cool, thanks. So who has read at this draft or skimmed it at least? Okay, a couple of hands at least, but I think could be more before we move forward in the direction of adoption. Okay, thanks.
Joel, are you on the Meet Echo?
I think so. Can you hear me?
We can hear you.
Great. Should I be putting on slides or can you drive that? Should I be putting on slides?
So did you send the slides?
I think so, but I can probably just put them on myself right now.
Yeah,
So.
if you can, I think we'll have to preview, but you ought to be able to do that. So let me stop
All right.
sharing. I'll let you do it. We have the technology.
All right, just need a moment. Okay.
Just another few seconds to figure this out.
Have I been cleared to share?
I think you have to request, and then we say yes. Yep, there we go.
I see.
So you should have slide control.
Okay, I don't actually see, I can only select slides from a list, but I
Yeah,
can't
it,
just,
it actually seems to be coming up. It says a new deck is being shared.
sorry.
Yeah. There it goes. He asked again. Is there a way to? Yeah, it's really weird. So where's the? Yeah, I don't know. There it is. Oh, okay. Screen is being started.
Okay, I see
There we
that.
go. All right, cool.
Oh, sorry. Almost there. Sorry, I think it might be best to go to another person until I figure this out.
Okay, cool. If you can also send it to us in email, then we can try to get them uploaded.
All right, I'll do that.
Can you hear me?
Yes.
Yeah, slides in mail. That'll be great. All right, cool.
Okay.
Yep. Share slides. And that's still in topics, right? Yep.
So I'm Richard Barnes. I work on WebEx, and you might have joined a WebEx. Some here might have used the product. Like, you click the join meeting button. You like to join quickly. When we do MLS-enabled meetings, you have to join an MLS group when you click the join button, and so we care a lot about the time that it takes to join a group. Next slide, please. So the problem is, when you go to join an MLS group, you have to download the tree. And the tree, it turns out, can get pretty large. So we have like hundreds of people, 1,000 people in a meeting. Each of those people has a certificate chain, actually, as we implement it. And so even with a little gzip to optimize out those intermediate certificates, it gets pretty big. 3.5 megabytes might not sound too bad. That was just one sample I did on a sample meeting. Might not sound too big, but like if you're on a mediocre internet connection, it can take a few seconds, and seconds matter when you're talking about this sort of user experience. So yeah, the goal of this work is to optimize that join time and optimize commits when we update the tree, because again, commits are linear, can be linear size if you have a sparsely populated tree. So basically, we want to make those go faster and let clients operate without having the whole tree on hand. Now there'll be some trade-offs here. We'll get to in just a second. Next slide, please. So the idea here is to add what we call light clients. And specifically, a light client is just a member of the group that doesn't have the whole ratchet tree. We'll end up having partial ratchet trees. So I'll have, for example, a proof that I'm in the group, but that just requires a log depth proof, Merkle tree style, that ties me back to the root hash of the tree. So if I'm a light client like this, I can join very quickly because I only need to download a constant size thing, which is the group info, and a log size proof that I'm in the group. Well, which I've got some concrete structs for in a second. So I can join very quickly, but I don't have enough information to really participate in the group. So I get the group secrets, so I can send and receive information, messages, but I can't in particular commit in the group because I don't know the full membership, so I don't know who I need to chem the new entropy to. So that's the trade-off here. The other trade-off is I can't authenticate everybody. I don't know the totality of who's in the group. And so this basically kind of lazy loads the authentication information. So you get confidentiality, you get shared secrets immediately, but then you get authenticity only when you download the full tree. So it's a trade-off. But if we do this, then if we do this and we combine this with the split commit stuff that Joel's going to talk about, we get this like very nice participation profile, efficiency profile, where you can be one of these light clients. You can passively participate. If you don't care about the totality of the membership and authentication, you can do all of this with real O log n guarantees and never have to do anything linear. It's a pretty nice efficiency profile. Next slide, please. We can skip that one. So what does this look like in practice? So we've added 2 structs to this to make the group go with these light clients. And the idea is basically that the DS takes normal commits, normal welcomes, and annotates them with just the extra little bit about the tree that you need to know in order to process this message. So when Alice goes to add Bob and commit to update the rest of the group, Alice emits a normal commit, normal welcome. The DS then looks at its local copy of the tree. Oh, Alice could do this as well, but the DS can look at a copy of the tree that it's maintaining, which is, I think, something that several apps are doing now. Take the extra tree and you use that copy of the tree to find exactly the right, the log depth stuff that the light clients require, and annotate the welcome and annotate the commit with just that extra information. So Diana down here, the full client, gets the normal commit, nothing added. Emma and Charlie get commits that are annotated with just the extra information for Charlie and just the extra information for Emma. And Bob, who got added, gets a welcome that's annotated, again, with just the extra information about the tree that Bob needs. Next slide. So when I say just the extra information, I keep making this like Merkle tree gesture. This is what I'm portraying. It's like we define a struct for these membership proofs, which, like I said, if you know Merkle trees, you know how this works. So you get a leaf node, which has a representation of members. It's got their chem keys, got their credentials, so you know about this member. And you get the direct path, the nodes along their direct paths, so you know the public keys and things like that above them. And you get the node hashes along their copaths. So it's a very normal Merkle tree sort of structure. With the only difference is that you get the node values, which you don't have in a Merkle tree case. So, but it's still log depth. So really all the structs here are just like taking normal MLS structs and adding a couple of these membership proofs to make things go. Next slide. So it's a little small, but basically we have this. I tried to like be clever and efficient to find the sender authenticated message thing, right? To take a message and add a membership proof. So if I'm one of these light clients, I'm in the group, I don't have the whole tree. In particular, I don't have Rowan's leaf. But then Rowan sends me a message, and I want to be able to validate the signature on that message after I decrypt it. So I need to know that Rowan is a member of the group, and I need to know his signature key and his credential, right? I like to know that what his identity is. So the idea of this sender authenticated message thing is you tag it on to whatever the signed message is. It gives you the right stuff that you need to validate the signature. So you can use that on normal private message for application data. You can use it on welcomes. You can use it on commits. So in the welcome case, this annotated welcome, you take a normal message, you wrap it in the sender authenticated structure so you can validate the signature, and you attach a proof that the joiner is in the group. So like that Bob is in the group when you're adding Bob. Yeah, Amen.
So I'm not sure I'm getting the idea of this. So the idea is just until you get all the tree, you're in this mode. So eventually become from light to a full member.
So I think I'm not defining that at the level of protocol. Certainly, I think the way I'm probably going to implement that is you join as a light member, you participate in that state until your tree is downloaded, and then you upgrade to being
I
a
guess
full
the part
member.
I'm struggling at is if I can't authenticate the group, like how I can participate in this group, like how can I send data to the group that I'm not authenticating the members yet? So I'm not sure what this by means because I can't send anything yet. I don't know who's in the group. So I need to download the list, authenticate everyone before sending out any data.
Well, you know who's in the group at least at the level of commitment, right? So in principle, you can verify. If you can ask questions, you can treat the tree hash as an oracle, and ask questions of someone who knows the whole tree and say, is Conrad in this group, or what have you. So no, I agree that like there's you're not going to want this all the time, but I think the assertion here is there are some application cases where you might at least temporarily not care about this,
Okay, last
about the
comment.
full authentication.
I'm surprised we went that path. I understand all the complexity of downloading the trees, but I'm surprised we went that path as opposed to simplifying key packages. And I will leave this here.
Fair.
Konrad Kobrock, just as a comment, what you could do if you have, it might not apply to WebEx, but if you have another messenger where you spin a conversation from an existing group, you could have inject a PSK from the existing group into the new kind of calling group. Then at least you know that it's at most the people who are in the existing group. So there's ways to kind of bound the membership to some degree.
Right. So in that case, like you wouldn't care about, well, you would get sort of a non-signature based authentication because you've already authenticated people.
Yeah, what's kind of implicit way of bounding the group membership. Yeah.
I think that folks, I've some other folks I've talked to have also thought about kind of almost broadcast encryption like things where you're mainly in a receive mode and you care about a specific other sender. You think of it like an IoT management thing where you care about authenticating stuff that comes from the controller, but you don't care about the million other devices that are in this group. So there's not the point of this is to be a bit generic. So I think that, yeah, you can do it in a couple ways. So anyway, just to skim through this a little bit more, the annotated welcome, you get a proof that you are in fact in the group, the processor of the welcome. And then the commit takes a little bit more stuff to make it go. So you get a proof that the sender's in there. If there's missing a little context in my head here, but you get the new tree hash because that's the thing you're going to verify stuff membership proofs against in the future. And you need to know if there's a path, which HPK ciphertext you need to decrypt. So you can figure out which step in the update path you need, but you need to know where in the resolution you are. And then for commits, because commits change the tree, you need to know that you're in the tree after that you haven't been removed. And you need to know that the sender is still in the tree. They haven't been, they're still a member of the group afterward. I included those because it seemed like you want those guarantees. It may be that those follow from some of the other stuff. So we may not actually need those, but seem prudent to have them there. One note here at the bottom here, you might think that a light client doesn't need to see the proposals because they don't have the tree. Do I need to see an add proposal if I can't see who's in the tree? It might be handy because I can verify that I get information that person's now in the tree. I can't use a remove proposal because it just refers by index, and I have no idea who's at that index. You definitely need to see things like PSK proposals or group context extension proposals because those aren't about the tree at all. You need to know which PSKs inject. So I think generally speaking, it's still a good idea to say, light clients need to see the proposals, even if they can't use all of them. They can at least verify that they match the proposal list and commit. Right?
What happens when a light client is removed?
You're asking how do they find out that they've been removed? Good question. I don't have an easy answer to that. All right, next slide. Oh, the last thing is that, as I mentioned before, Joelle's going to tell us about split commits, which are a way to take commits from linear size to log size per downloaded client. And so this thing integrates very cleanly with split commits. So we took commit and annotated it with some stuff. If you take split commit and annotate it with some stuff, it works pretty much the same way. And the cool thing is, you end up in this pure login regime. So if you've got your like IoT controller and your IoT device, the device can sit there and just do log stuff. The controller will still have to do stuff for the whole scale of the group. There's no way to avoid that. But everyone else, all the little devices who are in the group can just do login memory, login download. Next slide, please. Yeah, so that's it. Idea is we want these light clients. It's nice because you can go faster. With as we pointed out, some authentication trade-offs. And yeah, main change is to add some of these annotations to let people get just the bits of the tree they need. So that's all I have.
So yeah, I just wanted to note that the problem this is trying to solve is a real problem and it's a valid problem. And yeah, solving that problem probably bad design always requires some trade-off. And this is probably not the worst of trade-offs. That doesn't mean that it's perfect. I think it's quite dangerous actually, especially regarding authentication. And so for me, the prerequisite of an adoption call would be a very fleshed out security considerations section.
Yeah, I've got to start in that there. Karthik Bhargavan and Francisco Kiefer did some security analysis on this already. We can make sure that gets appropriately done. They built some formal models on an earlier version, so we might need to update them. But yeah, we definitely want to have that sort of analysis.
Britta Hale. So yes, there's a need for this. Totally understand, but also echoing what Raphael just said, it is dangerous, and I would not consider these minor effects on authenticity.
Not at all.
This is quite major effects on authenticity and understanding the group state as a joiner, and especially if they don't download the rest of the tree later, and you have no. If people kind of get a little lazy with this, I can see that being an easy slippery slope where implementations would become lazy with this. That sounds like light MLS is the way to go, and we just implement and leave it at that at the very top level. So I would say we need to highlight very carefully in those security considerations what should be done even after this initiation, like whether people retroactively check that tree or what happens further in the implementation. When implementations are looking at the trade-offs between this and just regular MLS, for end user perspective, it is important that they understand whether or not they're using this light MLS versus real MLS.
Yep.
And we shouldn't make a big distinction there.
Yeah, no, totally agree. We should be upfront about this. In fact, I think in the security considerations right now, there's actually some different security notions that you know, the smart security analysis folks defined, that Karthik wrote up, that are different from the guarantees you get from MLS. So I think we're trying to be precise about that and precise about what authentication guarantees you get. And yeah, as far as putting warning labels on this, have them rename it to like light MLS, red light emoji, or you know, whatever labels we need to get this. So yeah, let's talk about getting the text right.
Hey, yeah. So I think that regarding the implications of those security properties being different, I think the context really matters. And so, in the case where you're in, like for an instant messaging group of 10,000 people, the confidentiality guarantees for a group of that size are obviously much less of a concern than for a group of 10 people or 3 people. So, I yeah, I agree that we need good security considerations, and that we should also be mentioning specifically contexts where those different properties are appropriate. Thanks.
Do folks think that putting a couple of examples in the document of kind of application cases where this might be meaningful and good ideas? Okay, thumbs up on that. Yeah, great. Yeah, sounds good.
Deirdre Connolly. Yes, examples would be good. I would like to note that the blockchain community has experience with light clients. Specifically, I worked on Zcash. We had light clients that were the most popular kind of client for using the very large Zcash shielded blockchain. It did not include extra proofs like this, and yet it became the most popular one with less security guarantees by design because it was smaller. Um, I would caution adding this, making this a more appealing version of MLS that someone or implementers, adopters would use, with all these warning symbols and caveats and slightly differing security guarantees. I would like to look at making key packages smaller.
Uh, We can absolutely look at making key packages smaller. I think it's credentials that are a big thing. You can indirect credentials, but you still have a linear scaling, even if the linear scaling is slower.
Also, to Deirdre's point there, in terms of naming, I mean, it's very tempting to name this light MLS as far as lightweight computation, but we should make sure that even the terminology that we are applying to this kind of includes the sort of warning labels. So it's not just in the security considerations, but the warning labels themselves are whatever in this naming scheme hints at that. So.
Danger MLS. What was that about? Yeah, lazy clients. Yeah, for example, yeah. So just to mention, I mentioned security analysis that we've got. I've also got a PR on MLSPP that implements this, implements test cases. So we think it's basically functional. We have some basic validation of functionality as well as some validation of security. So, all right. Any further? Anyone else in the queue? Further comments? All right. So I think this is kind of basically thought through. We can do another pass to try and get some better warning labels and clear security considerations, but I think we're pretty well close to adoption here.
MLS without seatbelts.
Yeah, exactly right. I guess what I did want to say is that I did appreciate Raphael's comment is like, this is great, except this is what needs to happen before it gets adopted. It's very clear so we can understand what we need to do. I think if for other working groups, if you're ever trying to do one of these working group adoption things, that's the way to do it because it's very clear about what we want to get done. All right, Joel, you're up.
All right, I've requested slides, but if that doesn't work, maybe you could just drive them.
You have to. I have to vote yours.
Yeah. Okay.
All right,
It should be up.
there we go.
It's a big deck. Yeah, you always have pretty slides, man.
Nice. Okay, so we ready to go? Everybody hear me, right?
Yep.
Okay, cool.
Yep.
Here it is. This is a proposal by Marta and me and Marta Mularczyk. And this is it's a splittable commit, right? So let me go to the next slide. Right. All right. So what's the deal? Well, with MLS, the most expensive packets will tend to be commits. So in our sort of quest here to get things to be more scalable and support light clients and everything, we kind of looked at commits and we thought, why is this expensive? What can we do here? And if you look at commits, really, the key point is we got an entire update path in this commit. Okay, and that means a whole bunch of public keys, log public keys, but even more so ciphertexts. But if you switch over to a receiver, you'll notice things like, hey, the receiver actually only ever decrypts a single ciphertext, and in fact, can recompute at least some of these public keys themselves. So there's some redundancy here. Unfortunately, the problem is the redundancy is different for every receiver. One receiver will decrypt one ciphertext, a different receiver decrypts a different ciphertext. Okay, so that's sort of the starting point. That's the observation. That's this maybe slightly inelegance that we want to address with this extension. So enter split commits, or we've sort of rejiggered the terminology slightly. It's now splittable commits, partly because I was getting confused. So the draft will be updated shortly to reflect this terminology. But here's the idea. We're going to modify a little bit how MLS represents its commits on the wire, okay? And a little bit how they work too, the logic. And the basic idea is we want to come up with a commit message, a type of MLS message, this is a new wire format, which allows any third party, maybe the DS, for example, to take that MLS message that represents the entire commit and turn it into a personalized short commit for a target receiver, right? So, you know, based on what I just said, the idea here is like, they're probably going to be doing things like filtering out the public keys that this receiver could recompute themselves and only delivering the one ciphertext the receiver actually needs to decrypt. Okay, so there's some technical challenges if you want to take this approach, and these are ones that the extension addresses. So the main thing being that the update path, you can no longer put it in any signature in a MAC. You can't put it in the hash transcript because receivers will no longer receive the entire update path. That's the whole point, right? So then they wouldn't be able to check the signature or check the MAC or compute the next transcript hash. So that's the thing you have to work around. How can you get the same security as normal MLS, but change things so that none of those, you don't have to have, you don't need the entire update path to process a commit. So what we do is we introduce essentially two main structs and then sort of tooling structs around that. And the two main structs are what we call a split commit or an S commit, and that represents a splittable commit. In other words, a commit as uploaded by the committer. right? So that really has all the data you'd expect, an update path and all that, although it's authenticated a little bit differently than normal commits will be. And the other main struct is the per member commit. This is the individualized commit for a target receiver. So there'll be one upload of an S commit, but then downloads, everybody will download their own per member commit. And so then there's also a personalization commit algorithm, right? So in other words, an algorithm that allows anybody, you don't need any secrets to do this, you don't have to be part of the group, nothing, that allows you to take the S commit MLS message and turn it into a per member commit message for a particular receiver. So the minimal information you need to do this conversion to individualize the commit is you're going to have to know, the third party who's doing this has to know which ciphertext the target receiver will need in this commit, in that update path, and which public keys they cannot recompute themselves. And so those are the ones that are basically going to be from the leaf of the committer up to the first node, but not including that first node that's also on the path of the receiver. All right. And so, of course, if the DS, is following the ratchet tree, this information is quite immediate. Right? If they know the ratchet tree, all they need to know is who's the committer, who's the receiver, and they can compute all that for themselves. But you could conceivably have even less information. You could have sort of a pull, like the receiver comes online, tells whoever's doing this personalization, hey, I need this ciphertext and this public key. Please prepare, the rest for me. All right, so. How do we deal with this no signing, no macking, and all that of the update path? Well, okay, the committer basically leaves the update path out of the signature. That's the first thing. And the next thing is the transcript hash also now leaves out the update path, right? This actually has a very nice side effect of really simplifying how this transcript hash now works. The confirmed and interim transcripts are the same thing. It's just so the logic has actually become a lot easier. There's no sort of preparing the commit, computing part of the hash, getting the confirmation tag, going back, finishing the hash, like that all got much simpler. And so we also replaced then the confirmation tag with an epoch identifier. It's also slightly simpler. And so an epoch identifier is simply an exported value off the new epoch's key schedule. And we're going to sort of use that as our commitment for the committer to prove they know the secret key schedule of the epoch they're trying to create, which is basically what the confirmation tag is achieving for us as well. But of course, the difference is, well, first of all, the epoch identifier is not a MAC, it's just straight up an exported value. And of course, the transcript the whole key schedule doesn't depend on quite as much because we've changed how the transcript hash works. So it doesn't depend on the update path, basically. Right, and then the last change that we have to do to allow this sort of third parties to do this personalization is to not encrypt these ciphertexts and public keys in an update path, even when we're using the private message MLS wire format or some equivalent of that for these commits. All right, so those are the changes, sort of the mechanical changes to the protocol we need so that a third party can do this personalization. Which begs the question, well, what have we done to security here? And honestly, the takeaway is nothing. This meets the same security as normal MLS does. There is no price in security here, which maybe is a little bit surprising. So how does that work? Well, to give you some idea, okay, the first thing is the lack of encryption for the public keys and the ciphertext, even in MLS private mode. Intuitively, that's not such an issue because while the sensitive information, the sort of metadata information we're trying to hide will tend to be things like what's in the leaf, the credential, that does of the committer, right? That does still get encrypted. Same with all the proposals. Those are still getting encrypted. And that's fine because everybody needs those. Every receiver needs the leaf. Every receiver needs all the proposals. And so that does get broadcast. We can encrypt that. We can do what we usually do, put that into the transcript hash and so on and so forth. It's really just public keys and ciphertext inside this ratchet tree. So why should we not be so concerned about the lack of signature in MAC over this update path? Well, because if you look at what the signature and MAC do in MLS, well, the signature sort of authenticates the sender, and we are still signing all the data that is part of the commit, including this epoch ID, which does get broadcast to the groups. There's still a signature on this commit, we're still authenticating where it came from. And then the MAC, which is sort of this confirmation tag, is about proving that the creator of this commit knows this key schedule, right? And this is to avoid sort of attacks where things are being replayed, or we're trying to create decryption, the adversary is trying to create decryption oracles from people and stuff like that. So here this doesn't work, same as normal MLS, because the committer has to supply this epoch ID and in fact sign it. And so the epoch ID just commits to everything that matters about this commit. And for the same reason, we're also getting agreement, right? Agreement in the sense anybody who accepts this kind of split commit will end up in epoch that is the same. They will agree with anybody else who accepts the same commit, and they will agree on anything about the epoch with the person who created the commit. So we have the same agreement properties that we do with MLS. So really, the security properties haven't really changed, which is kind of nice, and what to some extent I think makes this a bit of a no-brainer. If everybody can be convinced of that, so to say. Yeah, I guess I said this already. The epoch identifier really plays a similar role to the confirmation tag, right? So it's kind of key to validating the security of this design. Okay, that was it, short and sweet. I guess where we stand in this process right now is, well, this is a call for feedback to some extent. I would maybe specifically also call out the fact that we're not encrypting the public keys in the ciphertext when we're using MLS private messages. For those of you interested in that mode, maybe think about that. Let us know if there are any concerns with that, with this private message mode. If you feel that's problematic or not. I think that's probably the one point that I'm not super confident with myself about myself, that this isn't an issue. So that's why I'm calling that out. Give us feedback. Yeah, other than that, I think we're relatively happy with the status of things as well. Okay.
All right, the queue. All right, the queue begins. Sophie, you're first.
So not having checked whether your proof that we actually don't need the signature is valid or not. So that might be the case, and that might be the better idea to do things. One alternative that we could think about is to also just put things in a Merkle tree and sign the root of the Merkle tree, and then the server can split the messages and just have that signature valid for whatever it needs, whichever part of the message it needs to be valid. The benefit of that is that you don't need to convince anyone that your proofs are correct. Maybe the drawback of that is that you probably shouldn't rely on public keys to be confidential, because the name kind of contradicts that. So maybe having the public key be officially be public might be a nice thing to have anyway.
Thanks. Yeah, there's a couple of things. So first of all, we do actually have this design in a paper. It's called server-aided CGKA, and this extension essentially implements that design that's in that paper. So yeah, there is a security proof and analysis and all of that. We did actually at the time also consider that approach with the Merkle trees. In fact, that's what we started with, and we only later switched over to this. It didn't seem like there was any difference in security, and it just made things bigger because, if you're doing these Merkle proofs, you have to then, somebody has to compute this Merkle proof or, buffer the entire tree. And then when you fetch as a receiver, you now have to pull this Merkle proof for all these values that you want. It's not a big deal. It's definitely feasible, but it just didn't seem necessary, as in we had a more efficient scheme that achieved the same security.
So I just want to get up and say that I think this is really good work, and I think we should adopt this. Joel, have you done kind of formal security proofs on this yet?
No, I mean, we've done pen and paper proofs. This is, I think, a crypto Eurocrypt paper. I forgot which one, but we do not have not automated reasoning proof, if that's what you mean.
Yeah, so that might not be a good thing. Might be a good thing to get done before we finish this, but I think this seems plausible enough that we can get started.
Mm-hmm.
It's 5 minutes. Okay, so next, Rowan, semi-private message.
You don't have slides, right?
Okay, so I wrote 3 versions of this draft, I think. The most recent, I believe, um, has the stated security properties. Um, so Conrad mentioned associated parties, and he mentioned semi-private message as one of the possible motivators. So just the way that the document is written right now, semi-private message does not use associated parties. So Mimi uses the Mimi protocol document as submitted in the current, the most recent version. It does use associated parties, and it uses it uh, specifically for the hub to be able to have a key that it uses for protecting the franking context, so that follower servers don't get to see that. It would also be very useful for being able to protect the group info. Um, it is not strictly needed for semi-private message the way it's formulated now. That doesn't mean that we couldn't reformulate it to use associated parties. Um, but I would want to see, I think the best thing for us to do with semi-private message and associated parties would be for us to have sort of a side-by-side comparison of these are the properties that we get. This is the implementation complexity if you use associated parties, and this is if you just do it standalone. But right now, semi-private message just chems the message directly to the external receivers. And the message is pretty small. The message just consists of encrypted copies of the keys that were used to sign the, in this case, commit or proposals. The last thing I wanted to mention is, by the way, if you were worried that semi-private message would be used to make application messages revealed to servers, do not be alarmed. This is not the droid you were looking for. It specifically is like the struct for semi-private message is incapable of being used for an application message. It only allows the content type commit and proposal. Does anyone want to ask anything or bring anything up related to semi-private messages before I sit down?
So yeah, I already shared my feedback with you yesterday, but I think it makes sense to do that in public as well. So I think it's absolutely good to have that. This microphone is very low. I'm too tall. Because it sits right in between public messages and private messages. So these are, private messages that can still be read by some people, and as Ron just said, you know who those people are. So that's why we need it. In practice, what I think makes sense, and what is not in the draft right now, is that it should actually really only publish to the associated parties the key material that is needed to decrypt a private message and leave the private messages intact. It's a very mechanical change, but I think that's the right thing to do. Yeah, and I wanted to start implementing it. That's how I discovered that. So maybe we discover more things as we try to implement it.
Yeah, and for the benefit of the room, the suggestion that that Raphael made would allow you to basically have a private message inside of the semi-private message, so that when you do fan out, you could actually strip off the semi-private message and just fan out the private message.
It's my only comment is let's just like consolidate this with associated parties. I think those two seem like they go together. So
Maybe. So yeah, what I specifically said is, if we're going to do kind of side by side, this is what it looks like if we do it using associated parties. This is what we do, what it looks like if we don't, and then we can reason about it and compare it concretely.
sounds like a good interim agenda.
Yeah. Thanks.
Okay, Raphael.
No slides for this one.
The slides on the first deck that I used, if you could reshare that. Yeah, if you can click forward until you find an orange slide. All right, that's the one. Okay, yeah, we can go straight to the next slide. So this is called additional wire formats. It's maybe a little too broad a title. Need to find another one. So what is this about? So the status quo is that currently both private messages and public messages have an AAD field where it can have additional authenticated data. That means that is data that is not encrypted, but nonetheless authenticated. Specifically, it's signed in the case of MLS. The data is sent in plain text, but so what we're missing right now is a way to authenticate data that is not part of the message. And so in other protocols, that seems to be the case. So next slide, please. So yeah, the idea is that applications could have their own data that they want to authenticate and they don't want to transmit it. So they have that locally at the endpoint. And the question is, how can you inject that data? So the proposal here is really easy. The idea is that instead of having that field that we currently have, the applications inject that field as the incoming messages are being processed. And so that data would simply be authenticated during that processing. Yeah, and I mean, in practical terms, we completely reuse the private message and the public message structs, but we strip the AAD field. Yeah. Next slide, please. So some alternatives that have been considered and discussed was we could also really just define a safe extension and then hash that additional data and put the hash in the current AAD field. That would also work. The downside is obviously that we have transmitted some data, which is exactly the hash. So it's not the most optimal way of doing that. Another one would be to use group context extensions. The downside here is clearly that that can only be done whenever we send a commit. We could not do that as part of sending an application message. Yeah, next slide, please. So yeah, one of the open questions is, in the case that that extension is being used, should that completely replace the existing mechanism with private and public messages or not, or could both be used? So the reason this is important is that for private messages, we need the secret tree, and we cannot reuse the same secret tree we already use currently. We would have to have the exact same one, but a different instance of it. So yeah, it's fairly easy conceptually. That's it. Any comments or questions? Mad?
I totally support this. I want.
Thought so.
Yeah, this also seems like a good idea to do some flavor of this. Could you just restate real quickly why you think we would need separate secret trees?
Well, I guess because of forward secrecy. If we start mixing the two, we would have to have at least, we could have the same trees, but then different sender ratchets.
Well, each step on the ratchet is per message. So
right.
Even if you're using different messages, they're using different keys.
So you mean reuse the generation?
Yeah. Well,
okay.
you would use the same hash ratchet,
mm-hmm.
but each generation would be used for one message type.
And you only decide on what kind of framing you want to use, essentially.
Yeah, exactly.
Right. Sure, maybe that can work. Yeah.
So given that, like that makes it basically free to have allow both these to coexist. I think it's in general. My preference would be to allow both of these to coexist, so you can either the application can choose whether it wants to send the AAD or not. The only simpler option that occurs to me, I'm not sure if this was on your slide, was that you could have an extension that says that uses the same wire format, sends zero length AAD and says, the application needs to provide explicit AAD.
But then you can have both because you cannot distinguish any longer.
Good point. Great. So let's not do
Right.
that.
Right. So actually there's one more open question since we have 1 or 2 minutes left. The question is, do we need any sort of signaling? Because the problem right now we have with that proposal is that applications need to know exactly what to inject at processing time. There's nothing in the message that tells them what to inject. So they need complete consensus on that. That might be okay, depending on the application, but there's nothing on the wire for that. So maybe something to ponder.
You mean something in addition to the, supported wire formats, leaf node extension, and required wire formats?
Yeah, something more specific like per message, in case you could inject different things per message. But,
Does anybody have a use case where they require that? Because I don't like that.
All right.
Okay.
Okay. I guess we're at the end of the queue. Thank you.
Just one minor process point. This does, because it's introducing a new wire format, would have a dependency on the wire format support negotiation stuff that Rowan mentioned. But I think that's another kind of obvious bug fix. So we can do both of them, or we can do it in MLS extensions. Yeah.
All right, cool. So we're at the end of the session. I just want to point out that there are a couple of other drafts that were discussed in the mailing. I know Brendan brought up the subgroups, and I guess Conrad has another one for virtual clients. So at some point, we'll try to figure out how to get one draft from those two people. I don't know how you guys want to do that, but we could do that during interim maybe. And we also have, I think virtual clients was another one that we talked about that didn't quite happen. We did get presentation for those, but they are out there. I listed them all in the meeting session thing. So the only action item that I think the chairs took away was a working group adoption call for PQ combiners. I'm going to try to send that today just to get it going. It's like 2 weeks. Maybe I'll make it 3 because I don't know if everybody reads their emails this week. Yeah, we will take a look. Yes, yeah, right. And I think that the other thing is whether we're going to have an interim. We're supposed to be polite and give everyone 2 weeks. Probably make it 3 because again, this week is tough. So I'm thinking like the week of the 25th, we could try to set up a time for when. I don't know. I still work on those days. What are you talking about? So we could do the following week, the first week in December too. I mean, I'm happy with that. I mean, I don't want to encumber the rest of the world with North American holidays. So, but we can shoot for the first week of December if you want. That's going to be tough. We'll probably do the first week of December. But all right, well, thank you very much. Appreciate it. I don't know what happened. 2 minutes early. This is what happens when it's crowdsourced by the people presenting. All right. Cool. Wow, that went pretty well. Yeah. Just gotta learn how to spell. All right, cool. So
Yeah, places you went.